Santi for reaching out during the week, Acid Laser Escanore, Mitch, and Katie for their contributions to comms, Adria for all of his guidance in the Common Swarm, Juanca, Griff, and Septi for a From Prey session, and Bye Bye V, Ivy, and Octopus for being the closest to superheroes in the TEC. I passed it to Nugget.
Yeah, hi. I wanna praise Mitch for the amazing work on the spec, and also the rest of the team, Lauren, Griff, Marco, Vitor, and Septimus with the forum posts. I want to praise Sam for reviewing my pull request, and I want to praise Octopus for the Praise Analysis video he uploaded to YouTube. And yeah, I want to praise myself for the forum posts I wrote and for other pull requests for the TEC Convert. And I'll pass it to Sam.
I would like to praise Fabri, Rodrigo, Gabi, Fabi, Fiore, Paul, Paulo, Ana Pereira, Pacha, Will Griff, Luke, and myself for the gardens, which is the cornerstone of the common Tao that we are designing. And I would also praise Mitch for Griff, Lauren, and the rest of the Params working group for the specification of the commerce dashboard. I will pass it. Oh my god, Paulo.
Wait, before Paulo goes, Sam, do you have self-praise? Two self-praise.
I praise myself for the gardens. There are two praises.
Nice too, Sam.
Okay, I also would like to praise myself for the giving all the help I can with the mathematical formulas, because I really love it, and I try to add them, solve anything with maths. For example, the impact our formulas, or I like to put maths everywhere. I praise myself for that. I pass it to Pablo.
Thank you, Sam. This week I would like to praise everyone who has been participating on the Impact Hours distribution proposals. I also would like to praise Nugan, Fabio, and Vitor for their work on the TEC Convert. I would like to praise Gabi, Fabri, Rodri, and everyone else on the Gardens team for doing an amazing work on the onboarding, on the Gardens onboarding project. And of course, I will have to praise Pavel and Sam for an amazing week here on the Give It House hacking. And an extra praise to Sam for helping me and on designing and specifying the requirement for an amazing library that we're building. And yeah, I'll pass it to YGG.
Hey everyone, I'll pass it over to Tamara.
Tam went too. How about David?
Hey, good morning, everybody. At least it's morning here in BC. I'd like to praise myself for diving on into this community heads first and just seeing what comes of it, and also praise myself for picking up so much tech education in the last 2 months. It seems like every day there's a new app to learn how to use, and then as soon as I learn how to use it, productivity exponentially grows in a great way. Also praise myself for making any progress in this messy room. Excuse that, no virtual backgrounds on this thing. I want to praise Suga for inviting me here. It was her warm and friendly invitation that made me feel able to knock on the door and join the community a few months ago. And I want to praise Chewy for being so patient with my question after question about where to go, what to do, and how to contribute. Thank you. And I want to praise Griff for his seemingly infinite energy and optimism. Seeing you bouncing around and smiling in these meetings makes me feel optimistic too. And that's it. I'll pass it to VVV. Is that pronounced right? I hope so. Oh yeah, I want to praise YGG Anderson too, because I see his name pop up, or their name pop up in the most random of places on the internet communities, and I'm like, hey, I know that person. Future thinkers community especially. Thanks.
I think Vi left the room. Maybe we can pass to Katie.
Thanks. Wow, yeah. So, David, I'm Stuga. So, and I'm also Katie. Thank you for that. So, praise to David for his praise. So, I'm going to praise myself for being a single mom and managing a headache I've had since Monday, and 2 little kids in the bath while we're having this call. And daily life is like that. Last night there was like squirting baby tomatoes all around the dinner table while I was trying to do some work with YGG. I'd like to praise myself for orientation stuff. And I'd like to praise myself a third time for the blog. So, and on that note, I would like to praise the folks who have really helped me a lot this week on that. So Heater, and actually Heater, Peter, that's the blog you're helping with, not the weekly update. So let me just get that in. And of course, Octopus, Magali, YGG, super grateful help, Mitch, and then just extra contributions from Craig and Marco. And last praise for Jess and Jeff. Jess also for the blog, and Jeff just for one-on-one fabulous insight. And let me look now with my giant headache. Oh, I want to praise Trent. Sorry, because I want to praise. I want to praise somebody I've never praised before, and also a token engineer. So I'm going to send it back to Griff because I don't know who's left.
How about Eduardo? Did you get to go?
Oh, thank you, Griff. I wanna praise myself for diving into token engineering. I had zero knowledge about it before getting into this project, so for me it has been a journey, and I thank everyone for that. I wanna praise myself for and Tam for the Impact Hours campaign, where we reach everyone up to 4 Impact Hours. I want to dish praise to Livy for, I don't know how she managed to her time into creating all these things and make it up and be always so kind to everyone that joins her calls and so on. I want to dish praise to YGG for his immense knowledge that he's willingly helping and contributing to the community. I want to dish praise to Angela. I have jumped in some of her calls, and they are amazing calls, and that's it. So I will pass it on to Juanca.
Thanks, Edu. Well, I will praise myself for coming to Cusco, Peru. I loved it, and I think it's an amazing place, and it was also a really good time for me to recharge myself and to connect with myself. So I think that's something I praise myself, because sometimes we all work all the time and we forget to do other things, and life is so wonderful that each experience has to be lived profoundly. And I would praise myself also for being here with you guys, because years ago this was like a dream. I wanted to work in DAOs and doing what I'm doing now, and like standing for my belief and contributing with my way. But I am going to take some more seconds to praise other people, and I am going to praise Jess and Jeff for leading and opening the Impact Hour discussion analysis, Griff for this idea of praising ourselves, Sem for proposing, and Griff and Sem for proposing for the Impact Hour analysis, Durgadas and Dan for helping me these 2 weeks with Gravity, Sep and Chewy for praise Quanting, Livy for leading the SoftGov working group and all the initiatives that are in there, Santi, Tam for being great stewards, YGG and Octopus and Angela for jumping into the praise analysis, and Bye Bye V for the Discord wizardry, and Ivy for typing all this praise. And I will pass to who hasn't gone. Acid Laser? Ya fue.
He went. How about LSR? Is LSR still here?
Yeah, it's Paulo. He already went. Let's pass it to Eli.
Chris.
Oh, okay. No wonder. Okay, Eli.
Hey everyone, it's my first time here, so this won't be too crazy long. I'll praise whoever came up with this idea, wonderful and great vibes. I'll praise Angela and Peter for roping me into this TE services project, and that's been a lot of fun. And I'll praise myself for coming around more than I have the last few months. So yeah, good fun. And I'll pass to Chris, I think. Gone.
Awesome. I'd like to praise RDF BBX and ViViV for doing all the work, sorting out the praise bot and missed praise and that kind of thing. So thank you. Praise to those two for all their work sorting that stuff out. And I'll pass back to Griff. Or to whoever hasn't gone yet.
I'll go ahead and take a stab at it.
Let's see. Yeah, do it. Thanks, Nate.
Okay, I'll do the self-praise, 2 self-praises, case studies, and my progress in learning Solidity. And then I will do my praise in the community. Ivy for Twitter and the praise aggregation. Mitch and Lauren for all the forum posts that you're doing. Chewy on the unbelievable amount of comms initiatives that are going on within this community. Eduardo and Zepti for the Hatcher guidebook work that you're doing. Tam for all the guidance and advice you provide us. Livia for all the perspectives on governance and informing ways for the intervention proposals. Octopus and YGG for the praise and impact hour analysis. YGG for TE labs and the TE services groups. Griff for just pulling this all together into a cohesive mission. Katie for the blog and external comms that you do on a daily basis, which is really awesome. ViViV for all the platform work that you do, keeping us on track and everything accountable. And I also wanted to add David, praise you for being new. We were all in your shoes at one point, so congratulations and welcome to the community. And I will pass it to the next person.
Trent. Trent, do you want to give 2 self-praises and then praise the community?
Let's see. All right. I guess this is what. Can you hear me?
Yeah, we hear you.
Yeah. Cool. Great. Yeah, this is I guess my first call on this. So, praise to the people who set this up. It is a really good vibe, like someone else pointed out, and praise to the invite to come to this and talk a little bit about TokenSPICE and share with you guys, some of the learnings that I've had there. Praise to the people who praised me for being here. Thank you. Overall, praise to just, I know so many of you have put in a lot of hard work to really get Token Engineering Commons off the ground, and Token Engineering too, obviously. So this is, I fear that if I start listing names, I'm going to miss many people. But I know that Griff and Jeff and Angela and others have done so much work. So praise to at least you 3 and many more, I'm sure. So I apologize that I can't be at more of these meetings. I just have, my time is stretched. But it's a pleasure to be here.
Thanks, Trent. And Pavel, I think you're our last one.
Yeah. Hi everyone. I'd like to praise myself for hacking in the Giveth house, going to Barcelona and learning a lot. I'd like to get praised, this prize to Sam for all his work in the Params and in the modeling thing, and to Paulo for the VM scripter library, which we'll use. Also, I'd like to give praise to Gabi and Fabri for reviewing my pull requests on the Gardens onboarding, and that's pretty much it. I'll pass it to Griff.
Thank you so much, Pavel. Man, I'm having internet issues. If my screen share doesn't sub in for me, but I want to start by saying welcome to the community call. It's another great one. Praise Ivy for setting up all the slides and updating the dates. So nice. If you love praise like we all do, don't be afraid to
Hey, Griff.
Griff, I don't think you can do both, man.
Yeah, I can.
Uh-oh, somebody stop him.
You can just pray to me in the
Hey, Griff, can you stop sharing?
Griff is dying.
Please, if there's any conflict in the
I can probably share my screen while he comes back.
Yeah.
Griff, can you hear us?
Yeah, but I'm probably not the right person to lead this call today. I'm hoping to just ask to
Take it, Livy.
Yeah.
Okay. Okay, here we go. So we're really tight on time and we have so much to go over. But there's also all the working group updates that are going to be great. So I'll pass it straight to Community Stewards and Tam to kick us off. You're muted, Tam.
Okay, cool. Actually, I'd love if can you just go to the slide that says decisions happen after advice process? We had a conversation in our retrospective around sharing. Thanks for adding that, Griff. It was excellent. We just had a conversation in our retrospective around decision space and what to make decisions on and how to make decisions, and balancing advice process with community decisions. So I know that Griff added this here very quickly, and we'll start talking about it more in our in each of our weekly calls. Okay, so let's get down to business. At the end of sprint 12, believe it or not, we have 12 sprints together. I think my screen is sharing well. And this is what our retrospective board looks like at the end of every sprint. We take some time to be introspective and ask ourselves, what did we do really well this sprint? What went great? Like, what did we knock out of the park? And what are the things that we could have done better? And lastly, for the things that we could have done better, what are the actions that we can take into the sprint? So you are welcome to jump into the board and see the inner workings of our minds. But what we decided to do as an action to improve is to go deeper than we have on this hatch readiness checklist, but to really identify every single critical to hatch task and make sure that there's a GitHub issue for each one of those, so we could easily see it on the ZenHub board as well. What we decided to do is add these issues, which we will do here on the ZenHub board. And our sprint planning happens tomorrow at 6 p.m. Everyone is welcome to join or watch it on YouTube if you're curious about how we plan our 2-week sprints. And what else do I want to say about that? Yes, there's still time for us to update and close issues before our sprint planning tomorrow. So the hatch readiness checklist. Each of the working groups are slowly signing off to say, hey, if we needed to hatch tomorrow, we'd be ready to hatch tomorrow. We are pretty close now. So there's going to be more discussion from Olivia and SoftGov on where we need to make decisions in order on the impact hour and data analysis in order to be ready for the hatch from the SoftGov and cultural build perspective. We have this list in our last blog post. The working group stewards have come together and said, these are the kinds of skill sets we're looking for. So if you match one of these skill sets or are interested in participating, please do come find either Suga, who is the orientation coordinator, or any of the stewards. What else do I have? Some stats. So I made a mistake last time and I only had 15 stewards. So I added the missing steward that I missed last time. But it's also nice to share this actually in this call. There are 15 stewards now in the TEC, and there are 11 working groups, and we have now over 400 people who have contributed and earned praise in the TEC alone. And the last thing I want to share is this, which we started just last week. It's the working group's weekly update. It's on the forum. So if you don't have time to be really deep in our community on all our calls or on our Discord, you should probably get an update by email with all the different things that are going on in each individual working group. So that's very cool. All the great stuff happens inside the working groups themselves. So without any further ado, I'm going to pass to Santi and Legal.
Thank you, Tam. All right, here, Legal. We are started working meeting bi-weekly, so we didn't have a meeting last week. We make sure all the documents have included the final params that we voted together. We have to go a couple of small minor changes that we still checking, but all of those documents are finished and have integrated all the params. Besides that, we've started last meeting. We started working on the covenant and the constitution for the DAO, and hopefully we might be able to jump into that tomorrow in our meeting. So we welcome you to come and join us. We meet at 4 p.m. Central European Time. You're welcome, and I hope to see you all there. And that being said, I'm all finished, and I'll pass it to Juan Carlos for the next. Thank you.
Thanks, Santi. We have a gravity survey that is open for everyone to fill out, and the idea of this survey is to identify what are the key needs of DAOs related to conflict management, and also to see how can we polish and improve our processes, because we have a step-by-step process. If you have any conflict within the community or with another member or with the workflow or anything, in Gravity you can have a safe space to communicate and to look for solutions. So if you need any support from us, you can fill this type form and we'll contact you. And we are professionally responsible for trying to be impartial and for trying to facilitate the dialogue people, and we are trying to design the second graviton training that is after July. And today we have our working group call that Durgadas will lead, and he will give us a decolonization talk. So that's it, and I will pass to Hatch Outreach.
Thank you, Juanca. Hello, everyone. So in Hatch Outreach, we are basically, as you were in this call, you have received praise, therefore you have impact hours. So for everyone to know, impact hours will be lost forever if they're not, if your trusted seed membership is not activated. So if you need help, if you don't know how to do it, just reach me out or Tam, and we can help you with that. Also, as we mentioned before, everyone with less than up to 4 impact hours has been contacted individually, and we launched this campaign to do so, and it has been proven quite successful. 75% of those with up to 10 impact hours are already a trusted seed member. Also, we have sort of changed. We have an AMA for Hatchers that used to be at 4 p.m. today. We cancel it, and basically the idea of this is we will probably wait until the Hatch to relaunch this space. But if any of you have any question, or you want to just ask a question or make a suggestion, just go to the Hatch Outreach channel here in Discord, and we'll be there for you. Also, we are doing 2 main documents. One document, it's a Hatcher Handbook, which is a document designed for how the params, once you get into the Hatch, will affect you. And this document should be ready by this spring or the beginning of the next spring. And then we have a closing working document, because the name of our group is Hatch Outreach. So once the Hatch is launched, the outreach, our mission is done. So we are preparing a document that serves as a guideline for other working groups to closure, and what kind of things do we need to have or know or pass on to other working groups in case we have. So that will be pretty much all. In case anyone here in this call have a project or something that would like to propose as a proposal for the TEC, you're more than welcome to send me a message so we can walk you through. So I will pass it on to Livy.
Thanks, Adu. Yeah, in SoftGov, we had a very exciting week to show all the praise analysis results that came from YGG and Octopus and Mohammed and Angela and all of the lab's crew that did so much work, and everyone that helped clustering the praise and categorizing the praise and helping us to arrive to the point we are now, that we can start making decisions. So we had a call last Tuesday, and we gathered a lot of inputs from everyone. What is everyone thinking about? What is the best proposal to make? And we have a token log instance that it's been taking a really long time for me for this to load today. So I hope there is no problem with it. I'll check with Wesley. But it should, oh, here it is. I just needed to refresh. So Sam and Griff submitted proposals already, and we're hoping to have many more that will have a great perspective of what are all the thoughts from the community in the direction we're taking with the impact hour intervention. So I hope everyone can participate, and the timeline we have chosen is, we extended a little bit from last time we talked, because we heard from some people that making proposals until this week, it would be very tight on time. So we're going to close the primaries on next Thursday. That's July 1st. So that gives a little more time to make proposals, and hopefully we have some days just for voting. So if proposals can be submitted until the weekend or until Monday, that would be really, really great. And we have 3 or 4 days just for voting. And then the runoff proposals will be created on July 2nd. and the vote of the runoff, since it's a reduced number of proposals, will run just from the 2nd to the 6th, and then we're hoping to hatch between the 9th and the 11th. And this is really exciting. This is the last piece for the hatch, so we're really hoping to have the max participation possible. And all of you guys in this call are stakeholders that can vote on this process. And there is an immense forum thread with 55 messages that you can get up to date about everything that is happening. And here is a little step-by-step on proposing and voting if you're not familiar with token lock. And with that, I'll pass to Septimus and the Transparency Working Group.
Thank you, Libby. Yeah, first of all, I want to say sorry because I missed at recording the prize. So it would be super cool if you guys could write it on the channel, and especially like not forget to praise yourself. And yeah, it would be super nice. And I'm so sorry again for missing that. And then for the updates, can you go on the next slide, Libby? Yeah, we meet bi-weekly, Monday 3 p.m. CET, and yeah, we have two little projects on work that are going on. That is the credential discussion management. That it's it would be super cool to have more engagement. But we also we're working on like who should have like and we also raised this topic on Omega. So Omega is also thinking on it, and And then we're also working on rules for different platforms, but for the people who have admin powers. Right now we're missing Halfpot, Medium, Forum, and if someone could help who have expertise on these platforms, that would be super helpful. And then for like we decided to put like the audits we have for the moment on the next slides. And we decided just to put like the audits we have and just announce them every once in a month, so people know what's going on with the audits. And I wanted to make sure like normally like the working groups that have yellow, it's not because like they are not being transparent, but it's mostly because of the business plan after hatch. That there are some blank spaces, and it's mostly that. And the working groups who do not have audit is because they are mostly new working groups that they are engaging with the TEC. And with that, I'll pass it to Omega.
So Laddie couldn't enter because the room was full, so she asked me to give some updates for Omega. So we're working on refreshing our system thinking with integral frameworks like Cinefin integral theory and the TE proposals, and formulating a TE proposal of who owns ethics and TE consilience. So this is being sketched and will be shared soon. And also we were working with, let me see if I can paste it here, this Miro board that has the updates from the type form. So we had 21 answers, and I put them all here so we can play with them and see, what are some of the answers for this first TE ethos type form research that went out. So feel free to look around too. And I'll pass to YGG with labs.
Livy, that's so cool that you were able to import the survey results into notes like that in Miro. And Septimus, that's so sad you missed the recording of the praise. I think this just shows how valuable Septimus is and that he's at the top of the charts for a reason. Luckily, guys, I got you. I recorded the praise, but I did miss some of it. I think I got about half of it, but I think it'd be really cool if every single person in this call jumps into the praise channel and dishes the praise that they said. That'd be a cool decentralized solution to this. So Tech Labs, whoever's on the slides, maybe go to the next one. Who's ever's screen sharing? I'll be quick because we're a bit over time. So praise analysis dashboards are up. So I have the links here, and go ahead and make proposals. There's 2 proposals so far. So jump in and make proposals. I want to redirect some praise to Heater because I've been getting praised for this TE Services initiative, but that's all Peter, or Heater is his tag. So go ahead and dish praise to Heater for that. It's super cool initiative, awesome stuff coming out of that. And that's tech coordination labs on Fridays, 9 a.m. PST, 6 p.m. CET, and hack sessions on Sundays. So I'll see you guys there. And I'll pass over to Griff for Params. Or let's see, comms, actually, Chewy.
Thanks, YGG. Okay, super quick. We meet on Tuesdays at 9 a.m. PST and at 6 p.m. CET. And do you have any content requests? Do you need like anything to facilitate communicating something that's going on in your working group? Please feel free to reach us out. We have a content and distribution repo. You can go in there. We also have a Twitter spreadsheet. You can go in there. You don't have to write the whole tweet. You just have to write the objective. We'll be hacking into this list many times per week, and we can draft whatever you need. So please feel free to jump in. And make sure you also check our Common Swarm weekly updates. And remember, we do have content workshops where we can hack around like anything that you have purpose for publishing or for whatever needs that you have in your working group. And that's it. I'll keep it short. I'll pass it to Griff in Params or Mitch.
I'm gonna take it from Griff because he's having some crazy issues. So just Params working group. We meet twice a week. We've got the Tuesday meeting, and then we've got the Wednesday hack session. So that's coming up pretty quick. What we've been working on is the Commons configuration dashboard. That's coming along pretty good. And so the first draft specs are almost finished for the design validation. And then on the back end, we've got a couple all-stars working and building the Python modules to get that going. So come to the hack session on Sunday. It'll be awesome. And after that, I'll pass it on to Commons. Sam.
I'm sorry. Thank you. So, well, we have a new height rehearsal since we did a mistake with the last one. It was not a critical mistake, but we just decided that it is better to start from the beginning. And this time we have the new community video. So it's integrated there in the Hatch frontend. There are also other updates. We have been refining the models for conviction voting and bonding curves that can be used for the Params working group and also for gardens. Paulo is working on an EVM scripter library, which is a library that will allow any DAO to be able to install, modify any parameter or any permission or anything actually, or mint new tokens or bar tokens in just one vote. And it has been something that has been very painful for the space during always, I guess. It was possible, but it was not easy. So we thought that in order to create the Commons Upgrade script, it was time for something like that. So we are overextending a little bit in order to have a tool that is useful for not only the Commons Upgrade, but for any kind of upgrade of a DAO, and also for the whole One Hive ecosystem. And also we have some front-end improvements at convertthecommons.org made by Nugan, and also Vitor have been working on adapting the front-end for the new type of contract that it's still not working, but there is also work happening there, and these are our updates. I will pass it to the spotlight that we have this week, which I don't know who it is.
We have Trent McConaughey from the Ocean Protocol, and he's going to go over TokenSPICE and kind of some of the agent-based modeling that he's working on. I know it's at the top of the hour, we're kind of running over late, but if you have a chance to stay, please stay and listen to his presentation because it's really awesome. So I'll pass it over to you, Trent.
Before passing to Trent, I just want to make a quick announcement that we have a hatch dress rehearsal. So please, everyone, click in here and go test the hatch. It's going to be very important for us to have feedback on that. And with that, I pass to you, Trent, with TokenSPICE.
Okay, hi everyone. Let's see here. Thanks for your patience and thanks for sticking around. I will try to keep this presentation to about 10-15 minutes. And yeah, let's get going. I'll share my screen here. Oh yeah, first of all, I forgot to do the shout out earlier to Nate, who invited me to give this talk in the first place. So thank you, Nate. I appreciate it. So with that, let's share my screen. Okay. Here we go. Okay, can you guys see this? Can you guys hear me?
Can hear you. It's still okay. I can see it now.
Okay, cool. All right. So with that, I will get started. So this is an introduction to SPICE and TokenSPICE, short version. There are long versions too. I've already put them linked from my website and from the TokenSPICE page if you want to look later. With that, I'll get going. So the outline of this talk is I'm going to talk about some flows from analog circuit electrical engineering. I'm an electrical engineer myself. 3 flows, pure manual, a basic SPICE flow, and a SPICE in the loop flow. Then I'm going to talk about similar flows that are possible for token engineering, pure manual, basic TokenSPICE, and TokenSPICE in the loop. And finally, I'm going to zoom into some details of TokenSPICE. Electrical engineering flows. So one of the people in this call earlier mentioned they love math, so here's some math for the lovers of math. If you are an analog circuit designer, this is basically sort of where you spend a lot of your time doing in the initial design phases. You are looking at some sort of topology on the left, and you're basically coming up with equations to try to model that. In this case, it's about trying to model the gain bandwidth. It's just a performance parameter as a function of GM1, that's a design variable, transconductance of transistor 1, and a load capacitance. And then, with skill and experience, it usually actually takes a lot of skill and experience, many years, typically a PhD's worth, you can do this quite well. And, there's equations for each different circuit, and, many equations for each different performance variable of each circuit, and so on. So this is what a lot of analog designers spend time at, day to day. They've been doing this since the 60s, and the flows have got more refined over time. Then in the 70s, along came SPICE. It was there was a lot of people trying to do circuit simulators, and the first good one that came out was something called SPICE in 1973. And ever since then, it's been refined. And so when you say SPICE to an electrical engineer or an analog designer, they think circuit simulation. So, including myself. I'm a bit of an analog designer, but I'm much more of an AI guy. But I've spent enough time in the world of analog design that, yeah, that's how it is. And building tools for them, as you'll see. So this is the overall flow for a circuit designer who wants to use a simulator. They basically do their initial manual design, where they've probably taken the topology from somewhere else, and then they size the design. They figure out, what in this picture on the right, it's like what resistance for the resistor, what parameters for the diode and the capacitor, etc. And they have different formulas too. From that manual design, where they've got the schematic and the parameters, then they say, okay, I want to simulate this thing. And they enter a netlist, and this the netlist is a bunch of text, like the tiny little text you see in the middle here. The next screen will show more. I think I have it. Yes. And they can enter that manually, or they can have a schematic editor to basically move symbols around and so on, and it generates a netlist for them automatically. And finally, they run SPICE, the circuit simulator, and the output of running SPICE. It comes out, it's its own CSV file, but there's always waveform mirrors and so on to help, and that's what we see in the bottom here. So this is the standard flow that analog engineers have used since the 70s, actually. And if you study electrical engineering in school, you're going to probably encounter this in second year, third year, fourth year. It's going to be one of the staples of the things that you do, and of course professionally too. If then inside, what does this netlist look like? So overall, if we have this picture on the top right here, how do you represent that as text? And there's a standard schema basically for SPICE. And in this case, it's for a circuit type called a diode clamp. And in general, the very top line of this, it's got a section for basically specifying the voltage source, which is one part. Voltage 1 going from node 1 and node 0. And then it has a few different parameters. In this case, it's specifying that it's a transient square wave with going from minus 10 volts to plus 20 volts and more. And then there's a capacitor, there's a diode, a resistor, and more, and it basically specifies, which different nodes they connect to. And then finally, once you have all of that, you specify, okay, I want to do different analyses, different ways of sort of peeking at the circuit with a computer. So you've got a DC analysis, an AC, and a transient analysis. Transient is time series. DC is, I won't get into it, doesn't matter. But basically, you're specifying different ways that you want the thing to sort of flex the circuit. And not shown here, there's also dot measure commands, which might say, I want to know what the current was over time at this particular node here, and so on. So the summary is, you're specifying how these, inside a netlist, you specify how the different parts are connected, and you specify how you want to sort of perturb the circuit, and what analysis you want to have, transient and so on, and what you want to measure. So that's a SPICE netlist. Once again, a standard staple, and this standard format for specifying it goes back to 1973, and people have used it ever since. It's part of the heart of designing chips to this day. But interestingly, what happened was by the mid-90s, computers had got fast enough that you could run SPICE not just once, but you could run a bunch of it at times in a row, because a small circuit like this on the top right, that might take 5 minutes or 20 minutes in 1973. But by 1995, it would take like 1 second. So you could say, okay, well, why not just simulate, say 10 simulations in a row for 10 different values of the voltage, the power supply voltage, for example, et cetera, et cetera. And that's what people started doing a little bit in the 80s, but with more advanced tools in the 90s. And it was in the 90s that I started getting into circuit design a lot, and the CAD tools for circuit design, especially what is called SPICE in the loop. So this is the idea, simply that rather than just doing a single simulation kicked off by the analog designer, they have a tool that runs a lot of simulations. They might run 10 simulations or 100 or 10,000, right? So the general flow is there is a manual initial design where the designer has that initial topology, the structure, and the parameters. And then the next parts is actually all managed by some sort of design or verification tool. It can be doing design, or it can be doing verification, or helping design or verification. And in there's 2 parts. There's choosing the next simulation and writing the netlist. So it spits out the next netlist. And then in the very bottom, it runs SPICE. But then, it chooses the next sim and simulates that, and loops and loops and loops. And the result, as an example on the bottom right, I'll give many more examples in following slides. This is basically there's, not just a single waveform from a single simulation, but a bunch of them. So this is standard practice in circuit land. What do some of these tools actually look like? Here's some examples. Here's one called Fast Design Sweep, and it's basically what it does is it does a bunch of samples across all the different design variables. Let's say you have 10 different design variables, widths and lengths, transistors, resistances, capacitances. It samples uniform randomly across that whole space. And with each point in that space, it does a simulation. So maybe it does 100 samples, and then with each sample, it simulates that. And then from those simulations, it builds a model or a regression model that maps the design variables that it sampled from, this 10-dimensional vector, to a single output vector, such as gain or power consumption or something. And then it has pretty plots, like you see. And this basically makes it really nice and easy for designers to sort of move around and explore different design spaces and see the effects of different variables. And these effects can be quite nonlinear. For example, if you look at the plot in the bottom right, you'll see that it's very curvy and stuff, right? And that means that as you change one variable, it interacts with other variables towards the output here. One picture above, the very middle plot on the right, you see that it's sort of straight lines in one direction. So that means that only one variable is making a difference, the y variable, and the X variable isn't making any difference at all, right? And the Z variable, the colors, is actually the where the changes are. So this gives you a feel of a tool. There's many other tools. This one here is simply for fast design space exploration. There's another one for worst case analysis. If you say, okay, I've got a temperature range from minus 40 degrees to plus 40, and I've got a load from 10 ohms resistance to 10 kilo ohms resistance, and maybe 3, 4, or 5 other parameters. Say, okay, tell me now what combination of these things of temperature, of load, etc., gives me the worst case power. That has the highest power, and has the worst gain, etc., etc., etc. And that's a tool that I've also had a hand in helping to build. And under the hood, what it's doing to do this efficiently, rather than looking at all the combinations, because there could be like a million combinations, it runs an optimization, a global optimization, and finds that worst case thing. And it basically then you can say, hey, I can now verify that this design is useful. And this sort of tool is now in use by most of the big semis throughout the world. NVIDIA, for example, uses it to verify every single chip that they ship. Here's another one where another tool that helps with design. It takes a netlist on the left, and it perturbs a bunch of different variables. It can be the design variables or the random variables, whatever. It takes a bunch of points in the space, and then from that, it simulates them with SPICE. And now it has 100 points or 1,000 points. The input points, such as design variables, and the output ones, such as gain, power consumption, whatever. And for each of those, it builds a regression model. But not your mother's regression model, not an ordinary regression model, but a white box one that you can actually see the formula itself. And you can call this symbolic modeling or white box modeling or symbolic regression, however you want to call it. And so examples of the results are on the bottom, where the very top row is for gain. And basically you can see there's a closed form expression for gain as a function of design variables, ID1, VSG3, etc. And you can see they're pretty complicated. We've got ln in there. We've got different ratios and so on. And other ones, to get the same error, you can be quite simple. So and it turns out that that's enough to model within just a few percent error, et cetera, et cetera. So this is just another tool that people can use to get insight into, in a closed form way of what things look like. And it's drawing from the simulation results itself. Another one is you can even go full on synthesis. You can say, you know what, I'm going back to here. What if instead of doing that manual initial design, you don't actually specify a structure like the topology or parameters? You just say, here's my space of all possible topologies and parameters. Go nuts, Mr. AI algorithm, and go find the result for me. And that's what it's doing here. And so you can see here basically what it's done is it doesn't just spit out one good result. This one, it actually spits out a whole bunch of results, a whole trade-off. In this case, it's for 3 different settings, A, B, C. Let's look at the setting on the right, the blue curve. And that is every single point on that curve is a different design. There's 2 different topologies, and each topology has a bunch of different sizings, 10 or 50 different sizings. And together they form this trade-off of gain, bandwidth, and power. So if you want higher and higher gain bandwidth, then it's going to cost you more and more power, right? So it's a trade-off. And pretty interestingly, right, at some point in gain bandwidth at about 1.8 gigahertz or so, it does a switch from one topology to another. And this is actually going from a single stage circuit to a 2-stage circuit, a folded version of it. So an analog engineer will look at this and be like, oh, wow. So this is another example of a tool that uses SPICE in the loop. In this case, it's actually using SPICE in the loop to automatically come up with the structure and the parameters itself. And there's a whole bunch of SPICE in the loop tools. We can break them roughly into 2 categories. One for verification, nominal verification, corner extraction, worst case analysis, Monte Carlo, and more. And for design itself, so where you're exploring the design space. You can do things more manual exploration, things like design sweep, sensitivity analysis. And then you can get more and more automated. You can do local optimization, then go global, or synthesis, where you're actually changing the structure itself, and then even variation aware synthesis, where you're changing the structure itself, but also accounting for all the different variations, random variations, worst case, etc. So that's basically a bunch of tools that can get built, and in fact, these are all out there for CircuitLand. So this is CircuitLand. This is where I spent almost 2 decades of my career basically building CAD tools for people with the AI under the hood. And it was always the AI part that I loved. So that was really fun. I'm trained as an electrical engineer, but AI was sort of my first love in tech. So then TokenSPICE. and token engineering. So I started with SPICE and electrical engineering. Now let's take this to token engineering land. And as a talk, right, I've talked about EE and the 3 flows for EE, especially analog circuits. Now let's, look at those 3 flows for token land. So similar to the flow you saw before, we can have a flow that starts with manual design, that then goes to entering a netlist, and finally simulating with a simulator for tokens, TokenSPICE. And on the top, the manual design, what do those schematics look like? I have a couple of examples from my work. One is the Web3 sustainability loop. That's the diagram in the gray. And another one is a model of a high fidelity model of ocean markets, and that's the one on the right. There's a lot more details on this in the TokenSPICE GitHub, by the way, but just to give you a feel at this highest level. And then to enter the netlist. So TokenSPICE is an agent-based simulator where you can have agents that are pure Python if you want, but also, critically, you can have agents that are wrapping Solidity code, and that Solidity is simulated directly on EVM in Ganache. You could actually use Ropsten and whatever else too, but it's just more convenient in Ganache, of course. So basically, your netlist is Python and Solidity together, right? And this is all, TokenSPICE itself is, all written in Solidity, and then it imports the smart contracts from elsewhere. But you can use, you can evolve that however you want, of course. So that's the heart. TokenSPICE is this agent-based EVM simulator. And then once you enter that netlist, and then you run the thing, and it gives you simulation results. In this case, on the bottom case, I'm giving examples of the ocean token count over time and monthly number of ocean token minted and burned over time. And this is from my simulations on Web3 sustainability loop. I worked on this, initially started about a year ago on this, just over a year ago, and it wasn't EVM based then. But then as I was starting to do the balancer MM simulations and stuff, I realized that I really wanted to have an EVM because I found myself copying and pasting Solidity code, trying to convert it to Python, and realizing it was super error prone. And I mean, why not just run the Solidity code? Ganache is sitting right there. So that's what I did, basically. So to zoom in on the netlist, right, what does a TokenSPICE netlist look like? The thing that you're simulating? Well, there's the Python on the left. So in this case, you can see you basically have a bunch of agents defined. Each agent is defined as a class. And it's purely open-ended, right? You can get it to do whatever you want. And then you add them together as a set, new agents 1, 2, and so on. So we've got a marketplaces agent, a router agent, and a burner agent, and so on. And each agent, basically, you specify what else it connects to. What other, just like in SPICE, you connect the different nodes to each other, same thing here. And they have their own parameters. This marketplace agent, for example, starts with $0 and 0 ocean. But later on, some of the other agents have, a bunch of $US for ocean. And then under the hood, some agents are EVM based. So for example, the pool agent under the hood wraps Ocean's bpool.py library, which is simply a driver for balancer pool, bpool.sol. And that's what we're looking at on the right, just a snippet of bpool.sol, one of the different swaps. So, none of this needs to get re-implemented. It's just basically, these contracts are deployed to Ganache, and the address it's deployed to, the ABIs, and everything else connects together. So this was SPICE in the loop, right? This is the basic one-step TokenSPICE simulation. But what's pretty cool now is you can say, let's have SPICE in the loop, right? TokenSPICE in the loop. So just like the analog circuit version, you start with the manual initial design with these netlists, and then you can say, okay, I want to do a verification. I want to sweep across 10 values of Ethereum gas costs, for example. I want to sweep across 10,000 different samples of different agents that I've randomly sampled, behavior like that. Or I want to optimize. And so whatever tool it is that you have, the flow is the same. Chooses the next sim or simulations, like one or many, and with each simulation, it generates the netlist, combination of Python and Solidity, and runs TokenSPICE, and gets the results, measures the results, and then loops as it needs. So that's TokenSPICE in the loop. What sort of tools can we do with this general flow? Everything you saw for Circuit Land. We can have a bunch of verification tools. We can have a bunch of design tools. For verification, nominal, corner extraction, worst case analysis, Monte Carlo simulation, and more. Same thing for design. We can have design sweep, local optimization, global optimization, synthesis, and variation aware synthesis. And it gets pretty interesting when we get to synthesis, because if you are saying, I want to do synthesis on the solidity-based agent, say like an AMM, then you're actually, what you're doing is searching through the space of solidity code or EVM bytecode itself. And what's cool is there's actually a fair bit of research on evolution and search in general through program spaces. And I personally actually did a lot of work in evolution through a grammar constrained space. So you could say, okay, my grammar is this subset of solidity, a bunch of building blocks, how they connect. And I'm going to search through that space. And so I've got actually code online that I reference here called Mojito that right now is tuned for circuits, but you could swap with SPICE for TokenSPICE, swap with the circuit building blocks with solidity building blocks, and then you're good to go, and you can be evolving EVM bytecode or evolving solidity code itself with TokenSPICE in the loop. So I'm pretty excited about that as a direction to go. This also points to doing things like, a live automated trading system that's, evolving ARB bots or whatever you want, right? And there's some interesting implications for MEV as well. So keeping going, almost done. TokenSPICE details. So the main thing is, if you're interested to learn more, it's all open source, Apache 2 licensed on github.com/oceanprotocol/TokenSPICE. It talks about what it is, right? It's an EVM agent-based token simulator. The agents are classes, etc. Each agent has its own wallet. And like I mentioned, they can also be wrapping Solidity, and that part is running on Ganache. It's still pretty young as software. I've tested it well and so on. So all the functionality and features that it has are well tested, but it still has some features that need to get in. Most notably, right now, if you want to have a new net list, you'll have to fork it and put that in sort of in a hardwired way. So that's one thing that's my next thing up to do. Also, though, of course, I encourage all of you, if you're interested, come and help me, build and extend this over time. My time is stretched pretty thin, so I can only spend a bit of time at this. But there seems to be a nascent community interested in helping to extend this, and that's wonderful. Inside here, how do you get going with it? So right below the top description, it talks about the initial setup. So the first thing is, I'll just get to it. You get Ganache running, and then you deploy smart contracts to Ganache. Here I'm giving an example with Ocean contracts, and from the Ocean repo, but you can have whatever smart contracts you want, of course. And you keep going, basically. It has a whole quick start to get going with, to the point where you are running unit tests, as well as then running the simulations themselves. Just to give you a feel of some of the sim results, this is non-EVM results shown, because the EVM part with the end-to-end is still a work in progress. Here's an example of monthly R&D spend from Web3 sustainability loop models. Left side is linear, right side is log, and kind of gives you a feel over time. And there are actual numbers for this, but we don't like to make this public because we don't want speculators to basically kind of run amok with just numbers that our simulators give. so we hesitate to make this public. But there's also what the marketplace's sales and growth rate over time. And then what is the Ocean token count over time? And then, of course, what we did when we designed, Ocean token was things like, do we want to have, 5% of token revenue burning, or 95, or what? Sorry, question? Okay. And there's more simulations yet. Monthly Ocean minted and burned, DAO income. So for Ocean has a DAO, a grants DAO. So what does that income look like over time? And we tuned parameters such that for the first 8 or so years, it's pretty steady. And after that, as the Ocean's fundamental valuation overtakes the speculation valuation based on our models, then the revenue will go exponential, actually. Maybe that will happen sooner, maybe later, but we basically tuned such that there's steady income for DAO, Ocean DAO, for the first 10 years, and after that, it goes up. So all this is really important, right? We asked and answered a lot of what-if questions, right? What's the effect of burning? How do we have a smooth distribution of tokens over time, etc.? So to conclude, just very quick summary. I started with talking about analog circuit design flows, focusing on pure manual, and pulling in basic SPICE, and then pulling in SPICE in the loop, and the amazing tools that can get built from that, and where I've had a lot of experience in that. And then how we can pull that into token engineering land with pure manual design, which is a lot of the practice now. And there's some nascent simulators, which are great. I'm a big fan of CAD, for example. And then TokenSPICE, which pulls in the EVM side of things. So we can do it in a very basic, nominal flow, But if we start to put it with TokenSPICE in the loop, we can start to have just wicked amazing results. Everything from like really great variation-aware analysis to account for uncertainties in a big way, to optimization, sweep, and full-on structural synthesis, searching across Solidity code, etc. And then, TokenSPICE, like I mentioned, it's pretty young, but what is there works quite well, and it has a lot of promise. And yeah, I encourage everyone, come and kick the tires of it, play with it, contribute to it. Yeah, so I will stop there and see what questions everyone has.
Thank you so much, Trent. That was a very valuable, in-depth explanation. It's so incredible to have this in our community. We are a little bit over time, and thank you so much for everyone who stayed over, and we can still have the space for questions. I just want to be aware that there is also a gravity call that it's going to be starting in the Gravity channel, and Durga Das is going to be talking about decolonization to us and all of the things we need to think to keep the harmony in our community. And yeah, for everyone who needs to go to Gravity, I really recommend. And also, if we want to stay and hear, have questions to Trent, that is also a very valuable moment to have him here. So I'll open the ground.
I have to go, but I thought that was really exceptional. I just want to say thank you.
Thanks, everyone.
Yeah, thank you.
Thank you.
Thank you.
Thank you, everyone.
Thank you, everyone. Bye.
Hey, Trent, I have one question.
Okay.
Have you ever considered the idea of like a plugin architecture with TokenSPICE? So is it possible maybe that you could have like a standard way that someone could package an agent, and then that could just be like a standalone repo on GitHub, and then TokenSPICE could essentially have like a net list. It would be a very distributed net list, so it could just basically name a GitHub repository to pull in a particular agent. Do you think this is possible, or have you seen anything like this with like standard packaging for SPICE simulator components like this?
So SPICE doesn't do it, but I think there's a straightforward way to do it in TokenSPICE, and it's the following. So the net list that I see is it is simply going to be Python code where it's adding these agents one at a time, right? But at the imagine at the top of that net list, it just does import library X, and library X just happens to be a repo on PyPy. And if you build new models, maybe there's a very nice simple flow to publish to PyPy, right? Make it even slicker than it is, right? So that's one way. We could probably do other ways too, to make it, rather than relying on the infrastructure of PyPy, because maybe that's a bit too heavy for here. There's probably other ways too, right? And I think it's a great question. So I guess also in Circuit Land, there's this idea of IP sharing for different building blocks and stuff. And a company made there's a big startup that did quite well on that called Atrenta, love the name. And that was about, sharing of the different building blocks. But probably in this case, Circuit Land there's probably better inspiration than Circuit Land for plugin architecture. Any more questions? You guys hear me?
Yeah, we can hear you.
Okay. Yeah, I guess any of you are interested to learn more. Actually, I'll put this link to the slides here for you guys, make it convenient. And if any of you want to, explore more, feel free to, give it a try, of course. I need to find the chat here. Where is the chat in this?
If you go to our community hall channel slightly above, under our chat channels.
Oh, I see. Okay. Okay. Slides from my presentation. There we go. I just shared the slides. Cool. Thank you very much. And also, if you go to TokenSPICE itself, like the on GitHub, it links to the slides as well now. So, and encourage each of you, if you're interested, go and give it a whirl. Right, go through the quick start, and yeah, I think it has a lot of promise. Right, I see it as quite complementary to CAD. CAD is really tuned for early stage design, where you're more iterating with the symbolic models and the equations and stuff. And TokenSPICE is more for a little later in the design and for design iterations and that sort of thing.
Thank you very much. That was amazing.
Thank you so much, Trent.
Thank you, Trent.
Great, cool. I guess with that, I will sign out and wish everyone a good evening or day or afternoon or wherever it is for you. Bye.
Thank you once again. That was amazing.
Good evening, Trent.
Cheers.
Bye.